For example, we have e into bracket xe minus xe comma ye, then b into bracket xb comma yb. So when the formula is changing y over changing x, so when you subtract the ye and the yb, so you do it ye minus yb. You're supposed to make sure that the one at the down is supposed to follow the same sequence, which is xe minus xb. If you change it as in ye minus yb all over xb minus xe, your answer will be wrong.
Okay, so basically we said something like this will be very wrong, right?
Yes, sir.
Yeah, okay. So now let's solve questions. Then for gradient of a line, there are more things that we can do, like a lot of things to do around gradient of the line that we can ever think of. So first, let's start with the first one. Um, Solving this one for me. So Kennedy, you can solve this one. No, but have you um hello Nobo, are you there?
Yes, I'm here.
Do you know how to find the gradient of a line?
Yes, I can try my hands on it.
Yeah, try this one. Nobo, you can try this one.
All right, the P.
Sure.
Okay.
Sir,
Yes, what do you
I
have?
got my gradients to be 4/3.
4/3. Okay, Kennedy go 4/3. Okay, try the next one. Let's see.
So the next one is 2.
So you are saying you got 2.
Yes, sir.
Okay, I will confirm all. Then Nobo, take this one.
Okay.
Sir, I got the third one to be the gradients to be -3/5.
Sir, my own the gradient is -6.
So for this one, I'm talking about this one. No, but is this one you solve?
Yes, sir.
Okay. So Kennedy, solve this one for me.
So the answer is 0.
So 0, 0, 0. He had 0. Kennedy say he had 0. Okay. Now, so no, but you say you had -6 for this one.
Yes, sir.
Okay, let me confirm everyone's work. So for this one, 6 minus 1, that will give me 5. 6 minus 2, sorry, 6 minus 2, sorry, that will give me 4 over 4 minus 1, that will give me 3. So yeah, that one is correct. So Kennedy, this one is correct. Noble's first one, this minus this, that will be -10 all over this minus this.
It's 2 minus.
2 minus, that will be 5. So the answer will be -2 instead.
-2 instead. Sorry.
Okay, sure. Now, Kennedy said, so this one minus this, -3/5 minus this. Yes, Kennedy, this one is correct. Now, let's look at this particular one. So, -4 minus 2 all over 7 minus 7. This will give you -6 all over 0. This is not -6. Now,
It's 0.
the reason why I brought this thing is that when you're finding the gradient and the bottom is 0, whenever the bottom is 0, we say the gradient is undefined.
Okay.
So this one is undefined gradient. So the answer is undefined. So let's take note of that. Whenever the bottom is 0, the gradient is undefined. When the top is 0, then the answer is 0. That's why I brought those two questions. So for this one that Kennedy brought, so the top is going to be -3 plus 3. That will be over 3 plus 2. That will be 0/5, which is equal to 0 because the top is 0. When the bottom is 0, the answer is undefined. Are we okay?
Okay.
Yes,
Yes,
any
sir.
question? Someone raise their hand.
Sir, please, I would like to I would like to throw some light on this point.
Okay, this one.
Yeah, for the undefined and the zero.
Okay, I'm saying that when you are done finding the gradient, you do the normal steps. When you have something like 0 over a number, when the top is 0, the final answer is 0. But when you have a over and the bottom is 0, this is undefined. The zero, the bottom can never be 0. A fraction can never
Okay.
have a denominator to be 0.
Yeah, it's true.
Sir, I was
Yes.
saying that I wanted to add some knowledge on what you were saying.
Okay, okay, let's go.
So I was saying that when the line is drawn and the line is in a vertical line as you place in the bracket over there, or the line is parallel to the y-axis, the gradient is always undefined. But when the line is parallel to the x-axis or it is in the horizontal line, the gradient is always zero.
Yeah, come again.
I was saying that
Yeah.
when a line is given and we are asked to find a gradient and the line
Yes.
is in a vertical line or is parallel to the y-axis,
Yeah,
the
parallel to the
gradient is always
y-axis.
undefined.
Yes.
The gradient is undefined.
Mm,
But when the line is parallel to the x-axis or the line is horizontal, the gradient is always zero.
that's correct. That's correct. The same is the graphical representation of what's happened over here. So when the line is vertical, when the line is perpendicular to the x-axis, when it's perpendicular, perfectly perpendicular to the x-axis, or it is parallel to the y-axis, it is undefined. It is the same as something like this. But then when it is rather perpendicular to this, then perpendicular to the y and parallel to the x-axis, the gradient is 0, as you said. That's correct. Thank you for that, Kennedy.
You're welcome.
Okay, sure. Now, I said there is more to gradient. We are not done here. So we found the grade. I need to write the values again. Please let's take note of the values again. The values again. So the first one, what was the answer? I think you say 4 over something.
4/3.
4/3. The second one, what was the answer?
-2.
-2. So this one, what was the answer?
I think it was undefined.
No,
The third one was negative 3 over 5.
-3/5.
Okay, 3/5.
So this one is the undefined one,
Undefined.
and then this one is 0. Okay.
Okay.
So now, what we found so far has been just the gradient. We need to find the angle. So when I was explaining gradient last time, I said how far or how tilted. So if you have the x-axis
We didn't bring my calculator.
and then the y-axis, and then you have a line going like this. We usually find the gradient, how slopey it is. But then we can also find the angle it makes with the x-axis. We want to find the
Yes.
angle it makes with the x-axis. So that's possible to find from the value of the gradient. We use the value of the gradient to find those values. So usually, generally, the actual symbol for gradient is small m. When we are seeing
Mm-hmm.
small m is gradient. So how do we find the angle? So the angle theta is
Tan
equal
theta
to
equal to.
tan inverse of the gradient.
Yes.
Tan inverse of the gradient. So when we say what's the angle that it makes with the x-axis, what's the angle that it makes with the x-axis? This is equal to this. If m is positive, meaning greater than 0, let's take that in mind.
Mm-hmm.
You use this formula if it is greater than 0. Trying to find the angle. So if you are asked to find the angle it makes with the x-axis, it is this formula. The angle is equal to tan inverse of m if that gradient is greater than 0. But if it is the other way, then it's going to be 180 degrees plus tan inverse of the gradient if m is less than 0. If m is less than 0, if the gradient is um, less than 0. Special cases. Okay. Now, what if undefined? If m is undefined, if m is undefined, if m is undefined, then the angle m, the angle theta is equal to 90 degrees. Let's take note of these key things. If the m is undefined, then yeah, it is 90 degrees. If it is positive, it is negative. We use it for the various cases like this. So yeah, we are going back to what you solved to find the angles. So what can happen is that I can just give you a line, like a pair of points, and say that these points are on a particular line. Find the angle that each line makes with the exercises. So then you have to know that first you have to find the gradient, then use the formula of tan inverse of that. Kennedy and this, do you have your calculators ready? That's the tan inverse on the calculators. Yes.
Sir, I have a
Go
question.
ahead.
Yeah, what's question?
Sir, please, so what if the gradient is equal to 0?
If it is equal to 0, put it in the calculator, you get the answer.
No, like the gradient is
Yeah.
equal to 0. Are
Yeah,
we going to use the, which formula are we going to use?
if it is equal to 0, the same is this one, right? Okay, let me do it like this. Greater or equal to 0. Are you okay?
Yes, sir.
Sure. So let's start with the first one. So this one is positive. It's positive. So the angle is just going to be what? This is for Kennedy, right? So Kennedy, what formula are we going to use?
Sir, please, we'll use the first one.
Okay, so what's your answer?
Sir, please, I'm coming.
Okay, sure. Use your calculators. There's tan inverse on the calculators.
It's on the tan. So shift tan.
Yes, please.
Alright, so my calculator is not here with me.
Hey. Okay, sure. So Kennedy will be helping us with all the angles then.
Yes.
Sir, please, I got 53.1.
53.1.
Yeah. Degrees.
Okay, degrees, yeah. Degrees is very important. So we are going to Noble's one. Noble, what formula are we using?
So the second formula.
Okay. So that will be 180 degrees plus tan inverse of -2. Kennedy, sorry, you have to be the only one to help us here.
Sir, I got 160.56.
116.50
degrees.
degrees. Yeah, that's correct. So next one, I think this is Kennedy. I think this was for Kennedy. Kennedy, which formula are you using?
The second one.
Okay, so get it. So let me call them theta one. So we working on it. This is theta one, theta two, and theta three. Just give me the
Okay,
answer.
sir, the theta 3. Theta 3 is 149.03
03.
degrees.
Okay. Then for Kennedy, undefined. Noble, what's the answer?
So it's 90 degrees.
Great.
It's fixed.
Thank you. No thinking about it. You don't even need a calculator. And the last one, tan 0 is what?
0, we're using the first formula.
Is what?
Tan 0 is equal to 0. Tan negative, tan inverse 0 is equal to 0.
Okay. 0, so it's 0 degrees. Right?
Yes.
So is there anything like that?
Oh yeah, there's no angle, so 0 degrees. We have 0 degrees, or that's the starting point. You have 0 degrees
Yeah.
or 360 degrees. That's the full angle of a circle.
Okay.
So yeah, the starting point and any point are the two of them. Are we good?
Yes, sir.
Yes, sir.
So yeah. So right now I'm going to give you just point, and then you let me clean my board so that you will not be seeing the formula. I will now give you 2 points and ask you to find the angle. Oh no, I think I should be able to give you multiple questions around that. So I'm going to give first one for Kennedy, the second one for to Noble. So um point A, 3 - 7. B, 2 comma -1. That's for Kennedy. And B, for Noble. So I haven't put the questions down yet. So C, 0 -5, and D is -1 comma -2. So what I want is one, find find one. You are going to find this. Kennedy, you will find this. And then Noble, you will find this. That that's it. And then number two, um so I will need Kennedy to find me theta. Let me call it theta one, and Noble will find me theta two. So whoever is ready should now prompt me. Are we good with the question? Any clarification?
All right. So does it mean we are finding the length and the angle?
Yes.
All right.
Sir, so first I got by line AB,
Okay. I'm
line AB to be
Kennedy is saying that
line AB is equal to 6.08. Then by theta 1 is equal to 99.46 degrees. So I have a question.
okay.
For the line AB,
Mm-hmm.
if they don't, there's no unit, so are you supposed to add like 6.08 units?
Yes. I wanted to say that. This answer that you mentioned right now, the 99.46. Which formula do you use and why?
I use theta. I use theta 1. Yeah, I use the second formula because
There's no
for
I don't
my
know. I don't know.
gradient
I don't know which formula is second formula.
I use the formula theta is equal to 180 degrees plus tan inverse of m, where m is the gradient.
Why? Why?
I got my gradient to be -6 and it's less than 0.
Okay, your gradient is -6. Let me see. Um, this -1 plus 6/2 - 3. Okay. No, but I done.
So I'm done with the DC, the line.
Okay. What do you have?
So I got root 50
Root 50. Okay. What about the theta?
or 7.0. Pardon?
What about the theta?
So I'm coming.
Do you have the gradients though for the theta?
Okay. I'm coming. Tan inverse -7.
Tan inverse of -7. Kennedy,
Yes.
put that in your tan inverse of -7. So what formula are you using?
So 180 plus tan inverse -7.
Okay, sure. Um, Kennedy, help us, and let me confirm the gradient at least. Negative 2 plus 5 all over negative 1. How did you get that?
So how did I get?
The negative 7.
So I found for the gradient and then
Yeah, I mean, how did you, what's the gradient? What did you do?
delta y over delta x.
Yes, so delta y is what?
So delta y is negative 2. Oh God. Negative 2 minus 5, which is so I'm coming.
Yeah, take your time. Okay.
Yes, sir. Which is 5. So I think it's negative 5 though.
Negative 5.
It is 5.
Check.
So I'm coming.
Give me the what formula you are using.
So now everyone, it's 3.
Yeah,
Oh.
take your time. So it's 3 over what?
3 over negative 1. So it is 3. Negative 3.
Negative 3. Take your time,
Yes.
okay?
Alright.
Yeah, so negative 3. Uh-huh. So,
So it's 180 plus tan inverse negative 3.
yes. So, Kennedy, are you there?
Sir, please, I got it to be 108.43 degrees.
Degrees. Okay. Okay. So we take our time to do that. So yeah, but the concept is there, right?
Yeah.
Yes, sir.
Okay. So now we are going to still ingredients. We are not done with gradient. Gradients, there's a lot of things to do with gradients. So the next concept is also going to be around that. Yeah. So I have this. We are going to find if a given set of points are on the same line or not. So if a set of points are on the same line, like more than 2 points are on the same line, we say those points are collinear points. Collinear. Linear just means line, like straight line. Co means like together, cooperation, like organization, like group of people doing something together. Co-founder, yeah, co something. So they are all linear on the same line. That's what it means. Co-linear means same. They are all on the same line. They are all cooperating on the same line. Basically, the 3 points are found on the same line. So collinear points. So we need to confirm in each case if a set of points are collinear points. So if I have a straight line like this, and I have a line at one point A, point B, and point C on the same line, then it is the same line throughout. So they all have something in common. That line has a unique gradient. The line has a unique gradient throughout. So we need to make sure that the gradient between any two of the points are the same. So if I take A and B, I find the gradient M1, and I take B and C, I find that the gradient M2. They should be the same. Once there's any deviation, then the 3 points are not on the same line. Are we okay?
Yes, sir.
So you can take
Yes, sir.
you can take AB and later take AC. Just make sure that you take 2 points at a time and solve for the gradient. Take another set of two, another set of different points of two, and use to find the gradient. If they are all on the same, they all give the same gradient, then you are fine. So I'm going to try the first one. We have A and B and C. So I'll take A and B first. So the gradient MAB. I'm going to do MAB first. So that was going to be, I'll do 4 minus 2 all over 3 minus 1. That will give me 2 over 2, which is 1. I'll do which one should we do? AC or BC?
BC.
Yeah. So let's do BC. That will give me 6 minus 4 all over 5 minus 3. That will 6 minus 4, that will give me 2. 5 minus 2 will give me 2, also 1. It means that once I use two different pairs of the out of the 3, then the 2 points are on the same line. But we can still confirm. Someone may later go and use AC. So AC, for example, that will be 6 minus 2 all over 5 minus 1. That will give me 4 over 4, which is equal to 1. So once you just take two of them, they work. So this confirms that since MAB is equal to MBC, then the 3 points A, B, and C are collinear points. Not all of them here are collinear. So I've tried to make sure that I solve one so that you guys will try this and this. So I'll give this one to Noble, give this one to Kennedy, give this one to Noble again, and then Kennedy will take this one. Let's see. You are confirmed whether they are collinear or not. I'm not interested in anything. So this one is true. I'll do T here. True. So when you are ready, just tell me whether your point is true or false. Basically, if they are collinear points or not. Are we good? Or should I solve another
Yes.
question?
No, we can. We can do it.
Okay, Kennedy, what about you?
Sir, please, I'm good.
Okay, sure. So I'll be waiting for the true or false. Anyone that's ready, let's go. When we find anything that is false, then you tell me why. But if it is true, yeah, we leave it so because they will all have the same grade.
Sir,
Yes,
I got my first question to be true.
true. Okay, what's their unique gradients?
The gradient is 5/2.
5/2. I'll use it to confirm. Ne-
So I got the first my own to be true too.
yeah, what's your value for your gradient?
-1.
-1. Okay, I will confirm all.
Okay.
Sir, I got my last one to be false.
Okay, this one, here this is false. Okay, meaning there, okay, why?
The first gradient, that is the gradient of points E and F.
Mm-hmm.
I got the gradient to be 1.
Okay,
Then the gradient for points F and G, I got 3/2.
3/2. Oh, they are very far.
So my own the second one is also false.
False. Hey, why?
Yeah. So because the first one I got 1.
Mm-hmm.
And then the second one I got 4/3.
4/3. Okay, yes. So that's correct. That's how I said the question. True, true, false, false. So yes, we all got it. So true, they are collinear point. False, they are not collinear point. Basically, yes. So now this is one tricky one for each of you. We are going to find the value for this is point A, X. So let me say SA and 2, point B, 3, comma 5. Find the gradient, find the value for X. If M is equal to -2. This is for Kennedy. You are going to find the value for S of A. You are going to find S of A if the M is equal to -2. Now for so let me do Kennedy. Noble, we are going with C is equal to C is 1 comma 3, D is 1 comma no 4 comma -1. No, let me, yeah, -1 if theta is equal to 10 degrees. Let's do it so that we solve them together. This is for Noble. Noble doesn't have the calculator.
Yes.
Noble, take the Kennedy, take the second one, and Noble take the first one. Sorry,
Alright, sir.
yeah. Noble doesn't have
Okay,
the.
sir. Sir,
Yes. So first, you take me through all the steps. Basically, that's what's going to happen. Who is talking?
sir, please. You said for Noble's question that did you start to find the ingredient?
Oh, sorry. You have to find this y of d. Okay.
Okay.
So I'm done.
Okay. So yeah. So let me hear Noble. So let me hear Noble solution. So Noble, we are
Say
listening to you.
X.
I mean, I want the steps. Okay.
Okay, so it's going to be 5 minus 2
Okay.
all over
Mm-hmm.
3 minus x
Okay.
is equal to negative 2.
Mm-hmm.
And then we cross multiply.
I want to know what I
So it's going
wrote.
to be, I wrote bracket open 3 minus x, bracket close, bracket open 2, 2, bracket close, is equal to 5 minus 2. So it's negative 2. Sorry, negative 2.
Okay.
Yeah. So it's going to be negative 6 plus 2x is equal to 3.
Mm-hmm.
And then we move the 6 to the other side. So it's going to be 2x is equal to 3 plus 6. And so 3 plus 6 is 9. So it's going to be 2x is equal to 9. Then we divide through by 2. So it's going to be 2x divided by 2x. Divided by 2, sorry. By 2 is equal to 9 divided by 2. So x is equal to 9 over 2.
Perfect. Perfect. That's correct. Well done.
Thank you, sir.
So I'm going
Okay, sir.
to Kennedy.
Sir,
Ken. Yeah.
so for this, first we have to find the gradient. So we have our points. M is equal to y minus 3 all over 4 minus 1. Then which is equal to y minus 3 over 3. So now we take the formula 180 plus tan inverse of m is equal to theta. So theta is 10. So our gradient is y minus 3 over 3. So we have 10 degrees is equal to, sorry please, say please, I made a mistake. The formula I used was rather the first one. Yes, this one. So the equation will be 10 degrees is equal to tan inverse of y minus 3 all over 3. Then now, since we want to set the inverse to the other side, when you set inverse of a trigonometric ratio to the other side, it becomes positive. So we have tan 10 is equal to y minus 3 over 3. Then now our tan 10 is 0.176 is equal to y minus 3 over 3. Then now we take the 0.176 over 1, then we cross multiply. So it will be 3 times 0.176 is equal to y minus 3. Then now our 3 times 0.176 is 0.529 is equal to y minus 3. So we set the negative 3 to the other side. we have y is equal to 3 plus 0.529. So our y is 3.529. That's what I got.
Okay. Nobody, you agree?
Yes, sir.
Okay. So I want to clarify on something. Why did you use this formula, not the 180 plus this thing? Because at the end of the day, all of them will give you positive angles. So why did you use this formula specifically?
Okay, so I chose this formula because that was like, to me, that was the easiest formula to use, because for the 180 plus the 180 is involved, so I chose this one to give me a smooth way.
Okay. 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 Good. So right now we, in a short time, we've been able to revise gradients. So all these things have been around gradient too, but we are not actually done. Though we are actually not done though. What what we'll do next time is that yes, so we are going to still continue the journey on gradients. Gradients will help us do a lot of things. Going to help us get the equation of a line, get a group, other stuff that I think in the next class we are going to cover everything around gradient. How what gradient can help us to do a lot. But then I'm very happy that you guys have been able to master, especially the tan theta, and you are seeing the picture now. Right. So now this is where that question comes in again. What is that new thing or that new recognition that you just made from today's session?
Okay, so the new information I was able to make is that we can find the angle of the line that we found the gradient of. So when the gradient is less than 0, we use the formula tan is equal to a, the theta is equal to tan inverse of the gradient plus 180. But when the gradient is greater than 2, we use the formula theta is equal to tan inverse of the gradient. And when the gradient is undefined, we take that tan theta is equal to 90 degrees.
Okay. No.
Sir, so I learned that if we have multiple points on the same line with the same gradient, it is called collinear points.
Okay. Good.
And then also,
Mm-hmm.
any undefined gradient is equal to 180. It's constant. Sorry, it's equal to 90. Sorry,
Yeah. When
90
do you have
degrees.
undefined gradient? How do you know that you have undefined gradient?
It is when um, the gradient is undefined, when um, we have the fractions, right? So I'm coming.
Okay, sure.
Forgetting the name of this number. Oh God. So when there's a number on top of zero in a fraction, I've forgotten
The
the name of
denominator.
that. The denominator, thank you, is
Okay.
zero.
Yeah. So now, sometimes you don't even need to look at. Now that we understand it, first sometimes you don't even need to calculate it. When the x values are the same, because there is the x value that will be at the bottom, right?
Yeah.
So if they are the same, you do the difference. That will give you 0 at the bottom. So once you see the points and the x values are the same, then the gradient is undefined. So the angle will be 90 degrees. Are we good?
Yes.
Yes, sir.
Yeah, that's what you see. So you don't even calculate for anything. So if the angle will be 0, then you look at the y values. But first check the x values first. Assuming we have something like -2 comma -3, we can even have it because that will be the same point. That will be the same point. You cannot even have it.
Yeah.
So just check the x values first. If the x values are the same, then it's undefined. If the
All
x
right.
values are different, you check the y value so that you don't need to calculate. Maybe you know the answer ahead of time. You know what you are expecting ahead of time.
Okay.
Are we all good?
Okay. Yes, sir.
Yeah. So,
Denominator. Denominator.
Rich Kennedy. So, what do you think about this point? What will be the um, what will be the angle?
The
The angle.
So we have to find the formula because the gradient to be zero because the y's are the same. The
So, if the
y
gradient is zero, if the
coordinates are the
gradient is
same.
zero, what is the value for the angle?
Zero.
Yeah. So,
Is
0 degrees, right?
Yeah.
Yeah. So this one, this so that's how you think ahead. You look at the point, then you should be able to tell what's going on. Are we okay before you even start solving? Right?
Yes, sir.
Uh-huh. So this one is just quick. After we understand the concept, before I'm just sharing this one, it's not anything. Now let me give one to Novo. So Novo, you take this one. What do you think about this? What's the angle?
So it's undefined. The
What?
angle actually is 90 degrees. Sorry.
Yeah, 90 degrees. Good.
Yeah.
So we are good today.